Dear children, today I'm going to explain how to write recursive function for decimal to binary and for decimal to octal. So first of all, you must see what are binary numbers and what are octal numbers, and how to convert binary to binary and decimal to octal. So first of all, in binary the base is 2, the digits are from 0 to 1. And how to convert? Suppose the number is 17, since the base is 2, so every time you have to divide this number by 2 and you have to store the remainder at the right side here. So here we have got remainder 1, then 0, then 0, then 0, and finally 1 is left with. So here from bottom to up we have to move, or if we read these values in reverse order we will see that it is 10001. So the decimal equivalent, the binary equivalent of decimal number 17 is 10001. In a similar way, octal number system is where the base is 8 and digits are from 0 to 7, and how to convert decimal to octal. This time in place of 2, we have to divide this number by 8, and every time we have to record the remainder. We have to store the remainder at right side. Now if we read these values, these remainders in reverse order from bottom to up, you will see that the equivalent octal equivalent of the number 100 is 144. Now we are going to write a recursive function that will convert decimal to binary. So here first of all you see that this is the function where the return type is void. The name of the function is find, and it will receive one parameter as the decimal number. Here first of all the base case, if the number is 0, then immediately return will happen. And after that, here what to do is I am just calling this function, dividing this number by 2 by the base, and here within this what to do is n mod 2. Here I am storing the remainder, but I am storing the remainder in the stack. In the previous video, I have explained how to create a stack in any recursive function and how to use what is the concept. So here, stack will be created. The purpose of this stack is that we are storing the remainder one by one, and when we are going to pop out all the values will be popped out in reverse order so that we can get the binary equivalent on the screen. Now see that, suppose the number is 100 here and the binary equivalent is 1100100. In a similar way, suppose here the number is 17. The binary equivalent is 10001, which was given in the example. Now here in the same program, I'm going to create one more function that will convert binary to octal. So here void find 1, and this time in a similar way the base case need to be defined. So here return will happen and find. This time every time we have to divide the number by the base. Here base is 8, so every time we have to divide this number by the base, and here if we n mod 8, what will happen here? Again these values will get stored in the stack, and so as we know that the nature of the stack is LIFO, so last in first out. So the remainders which we are going in the which are storing in the stack will be popped out in reverse order only. That's why the octal equivalent will appear on the screen. So here enter the number, and after that we can display here the octal equivalent is this. Suppose the number is 100. You see that, sorry, I have by mistake I have called the other one. Here, what is that? If n is 0, n by 8 and n mod 8. So what is happening? Why it is not coming? It is one more time. Suppose here, if it is not coming. Here, what is the problem in this code was that here I need to change the name of the function here. Actually, it was calling that function. So here, if the number is 100, so its octal equivalent is 144. Check one more time. Suppose the number is 200, so its octal equivalent is 310. So I hope you have enjoyed this video. Thanks for watching.